So in this question, we have a parametric curve, that is a curve defined by parametric equations, x and y in terms of t, and we're asked to find this area R. So when you have a parametric curve, the formula we use to find the area is to say that the area is the integral from the first time to the last time, so from t1 to t2, y multiplied by the derivative of x dt. And we know y in terms of t, so that's easy. And we can find the derivative of x easily. So we can say dx by dt is 6 cosine t, and that would then go into there. So we can then say that the area of R is, it looks like T1 and T2 given in the question are 0 and pi over 2. And y is 5 sine 2t, and x is 6 sine t dt. Then we can use the double angle formula to rewrite sine 2t. So that's equal to the integral from 0 to pi over 2. The 5 and the 6 give you 30. And sine 2t is 2 sine t times cosine t. And then you have the second sine t dt. So all I've done is I've replaced sine 2t with 2 sine t cosine t. So that's your double angle formula. And that simplifies nicely to the expression they've given us in the question. Because 2 times 30 is 60, and then you've cosine times cosine is cosine squared, so it's sine t times cosine squared t dt. And that is the expression they've asked us to show. So that's part A1 done. The question goes on to say, use algebraic integration to show that the area is exactly 20. So let's look at the area again. So the area was the integration from 0 to pi over 2, 60 sine t times cosine squared t dt. Now, how would we integrate this? If you look carefully, it looks like the derivative of cosine is negative sine, so it's as if we've got the derivative multiplied by the function, so we can use the reverse sine rule. Let me remind you about the reverse sine rule. So the reverse chain rule. So we know that if we have the integration of a function of x to the power n dx, and if it happens to be multiplied by its derivative, f dash, then the answer is f to the power n plus 1 divided by n plus 1. So this is the well-known form for the chain rule. We can achieve the same result if we were to use substitution. So you could use substitution and say u equals cosine. You could say u equals cosine t, and that would be du by dt. But I'm going to use the reverse chain rule because it just works so beautifully for this question. So I can rewrite the integration as let's take the 60 outside the integration. You've got your limits. I've got negative sine t times cosine squared t dt. And now I can say truly that the derivative of cosine is right there. So now it looks exactly like my chain rule. You've got the derivative multiplied by the function, derivative function. And this minus is there simply to cancel that minus. So I can say my answer is negative 60 times cosine t to the power 3 divided by 3 with limits of 0 and pi over 2. Now we just need to substitute the limits. So I'll substitute pi over 2. Cosine pi over 2 is 0, so that's convenient. So it's now minus 60 into 0 minus cosine 0 is 1, so it's 1 over 3, or let's say 1 cubed over 3. So that gives you 60 over 3, which equals to 20 units, and that's what they asked us to find. Now the question goes on to say that this is the profile of a dam, and there is a vertical wall of height 4.2, and there's a horizontal walkway of width mn, and that's what they are asking us to find, this width mn. So I guess we would need to find the equivalent values for xm, let's call it x1, and xn, let's call it x2. And to do that, we're going to have to find the equivalent values of t, because these are parametric equations, remember. So let's go back and write our parametric equation. We have x equals 6 sine t, and y equals 5, was it sine 2t. So I'm going to try to find the value of t at these 2 points, m and n. So that's what I'm going to try to find. So what's the value of t at m and n? So the easiest way to do that is simply to equate y to 4.2. So 4.2 equals 5 sine 2t. So 2t1, let's call it, equals inverse sine 4.2 over 5. That gives you 0.997. And because this is a sine, there's always going to be a second value. So T2 is pi minus, or 180 degrees minus 0.997. And that will give you 2.14. And then you can divide each of these by 2. So these are my first solutions, but the actual solution is going to be T1 is half of that, and T2 is half of the other. So 0.997 divided by 2 is 0.4985. And T2 will be, I guess, 1.07. So now you know T1 and T2. We can use these to find the value of x1 and x2, because these values can then be substituted directly into our expression for x. So I can say x1 equals 6 sine T1, and x2 equals 6 sine T2. So 6 sine 0.4985 gives me 2.87, and 6 sine 1.07 gives me 5.26. So Mn, if we look back at the diagram, is simply the difference between x2 and x1. So I'll write that here. Mn is x2 minus x1. So I just subtract these two numbers, and I get 2.39. And I think the unit will be in meters. And we can say that's, to two significant figures, 2.4 meters. So that is your final answer.